Correlation. The more important use for scatter plots is to investigate correlation between two numerical variables. Because I teach Year 12 General Maths, I have a pretty good opportunity to advance you, given that stats in Year 12 General Maths is just a slight extension of Year 10 stats. Year 10 only needs you to be aware of strength and direction. But it makes sense for me to teach you about all 5 things about correlation because you would get it. Okay? Take that as a compliment because most people are just like, bro, I'm not going to waste my time on that. You would get it. So, correlation between two numerical variables we describe with 5 different characteristics. The first is direction. Direction is how the dependent variable acts while the independent variable increases. So, the independent variable is always along the x-axis. So the independent variable increasing is going to the right. So if your y variable goes up as x goes up, we call that a positive direction. It's going up and to the right. If the y variable is going down as x increases, that's called a negative correlation. Is there any shape to these dots on the last one? No, so you would say I don't see any real correlation in this whatsoever. So what might be useful to you here would be these 3 graphs. Draw a little sketch of those. If it's going up to the right, positive direction. If it's going down to the right, negative direction. And random scatter, then I don't believe that there's a correlation there. Give you some time. Thank you for doing those pivot surveys. It's 21 now. If during the double you still haven't done it, please do so. Are you talking about correlations in psych right now? I overhear a little bit.
We're talking about independent, dependent variables and correlation.
Yep. So be strict about... That's why I do those blue notes, because definitions are strict. They're applicable in all subjects. The independent variable is the thing that you are changing on purpose. It's causing change in the other variable. Move on. If anyone needs the last little graphs, I'll let you scale. This is a property. Linearity is a property that you're not expected to be aware of at Year 10, but you might as well know about it now. It's self-explanatory though. If a correlation exists between two variables, the point's closeness to forming a straight line is called linearity. How linear does it look? So even though these points are scattered a little bit, does it look like they're forming a diagonally up to the right line of points? Just scattered a little bit. We would call that linear. What direction would this be? Right. Positive. Positive linear correlation. But here I've got some dots here. They're randomly scattered. But if I wanted to trace a line through it, is it going to be a straight line or is it going to curve up and then flatten down a little bit? So at this point and up to Year 12 General Maths, you would say, actually the 10 Extension Maths students, you might call that a logarithmic one. But we would just say non-linear at this point. Because why? Because it's not friggin' forming a straight line. So get a quick sketch of that, please. If it doesn't form a line, non-linear. If it forms somewhat of a line, linear. If you clean this out, you can have a matching one over. It's been there for months. Statute of limitations is 3 months. Think about it. Yeah, so if you saw money hanging out of an ATM, you can't just take it.
I mean, you can.
You can, but then it's a crime. But after 3 months, it hasn't been claimed. Yes, sir. All right, strength. This is the only other thing that you expected to know at year 10. How strong is the correlation? Once you've established that there's a pattern or a trend to the dots, however close those dots are to that trend is the strength of it. So do you agree that with this positive linear correlation, are those dots laying very close to the line? Yes or no?
Yes.
Because your definitions are very different to mine, but they tend to be... Okay, in comparison to these other ones, are these closer to the line?
Yeah.
You would say that's strong. The only difference we do at year 12 is I show you how to put the data in a calculator and it gives you a number for how strong it is. Okay? A number between 0 and 1. So that would probably be like a 0.9 or something. Okay? For your perspective at year 10, I'm already advising you anyway, just say it's strong when the dots are close. If the dots are a little further away from the trend, you would say moderate. And if they're super far away but you can still see a trend, you would call it a weak correlation. Some moments to get that, please. It's a little unfortunate you won't be able to use this discussion in your science practical because what is the independent variable in your science practical? What are you changing? The juices. Is that a numerical variable? No. So the order that they form on the x-axis doesn't mean anything. So you're not going to get a correlation like this. All you're going to get in your science assignment is like 3 bars to tell you how much you titrated with. All right, last 2 points are not year 10, but you would get, because you're my class. What is an outlier? If data points lie away from the main pattern or trend of the other data points, we say they are outliers in the data. But even my year 12s messed this up. Is this dot here far away from the rest of the data? Yes, but why is it not an outlier? It follows the trend, okay? This data here established that it's positive and linear. That dot, yes, it's far away, but it's still up there. It's on trend. Are these 2 dots on trend? Those are the outliers, okay? If they're away from what the most of the data establishes. Draw a quick diagram that resembles that, please. Causality. This last part we can have a bit of a laugh. I did some research about it. Might be applicable to the psych kids. You talked about murder recently. Yeah. So outliers. Data that's far away from the trend of the data and is not on trend. If it's far away from the main part of the data but it's on trend, it's not an outlier.
That's it.
Right, this last point about causality, it's not mathematical, but marking your DIs, you've shown me most of you have shown me a good knowledge of the abilities, the things that sit behind statements. Unrealism. So all we are doing when we look at a graph like this, right, all we know for sure is that this data, as the X data increases, what's happening to the Y? It's going up. Okay? But that doesn't mean X causes an increase in Y. You need to look deeper into it. So please note that correlation just means that we observe how one variable changes as another one changes. We can't assume that the independent variable is the reason for changes in the dependent variable. It is just an assumption. Okay? If you can explain that the independent variable would at least partly affect the dependent variable, then we can say there's a causal relationship. That's causal. Please don't do like my year 12 said it was a casual relationship. That's when people just bump uglies, okay? Causal is saying that one variable causes change in the other. It's important to consider this because there are many spurious correlations. Does anyone know off the top of their head what spurious means? You don't? It's almost like fake. Okay? There's a website, Tyler Vision, that has a bunch of spurious correlations. I'll show that now. No, actually, I won't show that because this one's more relevant. This was done in 2023. There was a study done in New York, in America, where they found in 2009 that the murder rate, so the independent variable, how would I describe this correlation? Is it positive? Linear? Is it super strong? Sort of moderate to weak, okay? But generally, what is that graph saying? As there's more murders, there's more ice cream sold. Do you reckon there's a legit explanation for that? Is it? But this would be an example of, it's a correlation, it's not causal yet. Same thing, they looked at this data, ice cream sales and drowning death. That's a little stronger. That's probably more moderate. It's still a positive linear correlation. So are we trying to say that ice creams cause people to die by drowning, and do ice creams also cause people to murder each other? Is that what those graphs are suggesting? That, okay? But can someone, you wouldn't know, but can someone suggest maybe what's in between? Maybe what are we missing here? Yeah.
Well, with the drowning deaths and ice cream sales, in the summertime, more people would be buying ice cream.
That's what they
than,
found.
like swimming. So.
That's exactly what they found. So these are true things happening. They're correlations. But what's missing in between is that if you were to do a graph of temperature along the bottom, would there be more ice cream sold as the temperature increased? Good. And also, when they did that as well, and they did temperature versus murder rate, that also increased. So there's an actual causal relationship in between that's not evident here. People are more aggro when it's hotter, and people are also more likely to buy ice creams when it's hotter too. Okay? And then lastly here, this is just an applicable one because you guys are young. There is a strong positive correlation between iPhone sales and falling down the stairs. Do iPhones cause you to fall down? Actually, maybe they do. Can someone explain what's missing there? And then just like get run over or fall down the stairs? Yeah, it makes sense. Okay? But don't just jump to the graph and say it's causal unless you're trying to make a statement for people that aren't intelligent enough to think in between. Okay? Unfortunately, you're in a society where people just throw graphs at you and you just interpret it at face value. Okay? So